In this video, we're going to get a quick look at determining whether we're dealing with paired sampling or independent sampling when we're working with two population means. When we talk about paired sampling, we have paired sampling when we have two different samples and each number in sample 1 corresponds to exactly one number in sample 2. There's going to be some sort of relationship that connects those two numbers. And then when we talk about independent sampling, that just means that there is no such relationship. There's no relationship between the numbers in sample 1 to the numbers in sample 2. This matters a great deal to us because the process for hypothesis testing, depending on whether we're working with paired data or independent data, looks a lot different depending on what data type we have. So at the beginning of our problem types, we're going to have to make the determination of do we have paired data or do we have independent data, and then that's going to inform how we do the rest of our problem. I can't proceed with that problem without knowing what type of data I'm dealing with. So let's hop into our examples. Example 1 right here says compare the artery thickness at the beginning of a study and after 2 years of taking vitamin E for the same group of patients. Now it turns out this last part right here, the same group of patients, matters a great deal for me. So what I'm imagining, I think it really helps to imagine what this data would look like. How might it be presented? So if I'm imagining this, we kind of have before data at the beginning of our study, before taking the vitamin, and then your after data after the 2 years. And what is really important is that we're working with the same group of patients before and after. So what I'm imagining here is that we've got patient number 1, we've got their before data and their after data. And then patient number 2, we've got their before data and their after data. And then patient number 3, their before data and their after data, and so on and so forth for however many people we have. And what I want to ask myself is, if I look at the before data, if I pick one number from the before data, is that going to correspond to one particular number in the after data? And in this case, I'm just going to come right out and say it. Yes, it does. This is dealing with paired data here. Because if I look at patient number 1's before data, I probably want to compare it with patient number 1's after data, because that's going to tell me how that particular individual responded before versus after. I probably wouldn't want to compare patient number 1's before data with patient number 2's after data because they're different individuals. They might react differently, and I want to understand how each individual is affected by, in this case, the vitamin E right here. So as a general rule of thumb, anytime we're working with before data and after data, that is almost always going to be paired data because I want to compare each person's before data with their after data, and I want to be able to compare those scores or their measurements, whatever it may be. So in this case, we're dealing with paired data, which is what we're going to be looking at primarily in 7.2. We'll talk about independent data in 7.3. So moving on to our second example, it says assess gender-related salary gap by comparing the salaries of randomly sampled men and women. So again, I'm just going to imagine what my data would look like if it was presented to me, and I've got here's the men's salaries and perhaps here's the women's salaries right here. And I'm going to have a list of men's salaries. So you would say, okay, here's this person's salary and that person's salary and that person's salary, and then I would have a bunch of women's salaries over here as well. And what, again, the question I want to know is, are we working with paired data or independent data? Meaning, if I were to select one particular man's salary, is that going to correspond or have some sort of relationship with one particular woman's salary? So do I know, like, if I pick man number 1's salary, does that correspond to one particular woman's salary over here? If it is, it's not clear to me. I don't have that sort of information. I don't know what sort of relationship we have between these men and women, and I would actually go so far as to say in this case, well, they're randomly sampled men and women, meaning there is no relationship between the men in my sample and the women in my sample. So if that's the case, if there is no such relationship, that means we're working with independent data. Independent data. Now, if I had a little bit more information, if I knew I was looking at, say, like a husband's salary and his wife's salary, then yes, I could talk about the relationship between those two. But if that is what's going on here, it's not clear to me. And if it's not clear, we have to assume we're working with independent data. So if we don't have that relationship, that means we're working with independent data. Lastly, number 3 down here, it says we randomly sample 50 items from Target stores and note the price for each one. Then we visit Walmart and collect the price for each of those same 50 items. So one last time, I'm going to imagine, what would this data look like? Well, we've got our Target prices, and then we've got our Walmart prices. And this says we're randomly sampling, in this case, 50 items from Target. And so we might look at the price of, a t-shirt, and then we might look at the price of, a mug that says live, laugh, love on it or something like that. And we've got all these different things. And we look at the price of, a particular book that just came out, something like that. And I'm going to look at the prices of each one of these things. I'm going to look at the price of the t-shirt at Target and the price of the t-shirt at Walmart. The price of the mug at Target, the price of the mug at Walmart. The price of the book at Target, the price of the book at Walmart. And what I want to ask myself is, if I look at the prices from Target, do they share some sort of relationship to the prices from the items at Walmart? So if I were to pick just one, like if I were to pick the price of a t-shirt at Target, is there one number that I should compare that to from the Walmart data set? And in this case, hopefully it makes sense. Well, I should probably compare the price of a t-shirt with the price of a t-shirt from my 2 stores, right? It probably wouldn't make sense for me to compare the price of a t-shirt to the price of a book, something else. Those are 2 completely unrelated things. I probably want to compare the prices of each one of these 2. So the price of a t-shirt with the price of a t-shirt, the price of a mug with the price of a mug, and so on and so forth. So if we have that pairing, that means that, yes, we're dealing with paired sampling because there is that relationship between these 2.